This discovery activity for Unit 5, Lesson 1 is intended to be done on your own or with your table group. It should be review from things we did in the fall semester. This graph shape is it's a quadratic function. The equation would be y equals x squared. And that is what we studied in Unit 3. Then the next section here asks you to graph the inverse of the function. We did this in Unit 1. Inverse. Which is a real throwback unless you studied inverse in reviewing for your semester exam. The inverse for any graph is a reflection across the line y equals x, which is this line here. And you can find the graph of the inverse by choosing some points and then writing them backwards. If I exchange x and y, or switch the points, then I could get points to create the inverse. So on my original graph, I have x is 0, y is 0, x is 1, y is 1, x is 2, y is 4. This is f of x equals x squared. So on the inverse graph, I would have these backwards. I'd still have 0, 0. I'd still have 1, 1. So here these graphs are on, or these 2 points, are on both of the graphs. But then instead of writing 2, 4, I have 4, 2. And this inverse is y equals square root of x. I could continue graphing inverse by adding more points. What if I did here negative 1, 1? And for the inverse, I would have 1, negative 1. However, square root of 1 doesn't actually equal negative 1. So 1, negative 1, this point is not on my graph. What you come to find here is that when I take a square root, whatever number that I am taking the square root of has to be 0 or positive. So if I limit it and I only allow x's to be, or whatever I'm taking the square root of, if I'm only taking a square root of 0 or a positive number, then this calculation will always work, and that means that I'm only graphing half of the curve that I had when I had a quadratic. This allows me to draw a function. This is important. So it's only half of a curve. Here in the bottom, if I drew the full half using this switch the points thing, then the inverse is not a function. I just answered this. What can you do to make it a function? So the rest of the curve goes down here, actually. But we're not going to include this part. The part that I highlighted makes it not a function. So only use x's that are positive or 0. So it will be a function. We didn't do inverse algebraically in Unit 1, but algebraically it works the same way. Inverse means that x and y trade places. So using equations, I would say if I have y equals x squared and I need to find the inverse, then I'll trade places here and I'll get x equals y squared. And then if I solve for y, I would take the square root for both sides. And I would get y is equal to square root of x. Square root of y squared is y. I'll just let this be square root of x. And this will be true when x is 0 or positive. So the parent function of the inverse is y equals square root of x.